Hello, everybody, and welcome back to another lecture in Geography 341, Weather and Society. I'm Dr. Zach Hilgendorf, and in this lecture, we're going to be talking about three very related phenomena, but they're all called different things: dust storms, sandstorms, and haboobs. So let's go ahead and dive on into it. So, what is a haboob? That's where we're going to start. So, we're going to talk about all three of them. But haboob was originally the name for a dust or sandstorm in the northern parts of Sudan, most commonly observed between May and September during the afternoon and evening. The name is derived from the Arabian word hab, meaning to blow, or wind. Also, it means a few different things, but to blow is the common interpretation and has been used by the meteorological community for nearly 100 years. Although the word originates from Arabic to describe the dust or sandstorms in northern Sudan, the term is now commonly used to describe any wind-driven sandstorms or dust storms in arid to semi-arid regions worldwide. Haboobs have been spotted worldwide, including in Central Australia, parts of America, from the northwest corner of Mexico to the edge of the Great Plains. And they're the result of microbursts. So a haboob results from a microburst, or what we've come to learn is an intense column of sinking air within a thunderstorm, which, as it hits the ground, spreads out in all directions and carries sand and dust particles at speeds of up to 60 miles per hour. The lofted particles can reach heights of nearly a mile and can extend up to 100 miles wide. So you can kind of see the two graphics here showing what's going on. So you've got your intense storm and the downdrafts from that microburst. If we're looking on the left here, it's basically kicking up dust as it descends and spreads out as it's hitting the ground. Flowing this way here. So that outflow stirs up dust, as we see in that graphic on the right. You kind of have these, you notice kind of these circulating wind patterns like that. And as it's doing so, it is stirring up dust. And with that dust can come a lot of different things like fungal spores. There can be silica, things you don't want to breathe in. So these have a pretty significant health risk associated with them. But we can kind of see now, at least, how a haboob forms. Now, sandstorms or dust storms are a little bit different. Now, they're caused by the same things for the most part: thunderstorms, the jet stream, or just a lot of wind blowing over an area. So, where a haboob is on the leading edge of a storm, so you have that microburst, here, a dust storm or a sandstorm just needs a lot of wind. The difference between a sandstorm and a dust storm just comes down to particle size. And distance with which the storms have traveled. So you can see most of our dust-sized particles come from things like, sorry about that, things like clays and a little bit of silt, versus sand, which is much larger particle size, 2 to 0.5 or 0.05 millimeters, so 5/100ths of a millimeter. Clay, less than 2/1000ths of a millimeter. Silts, less, 2/1000ths to 5/100ths of a millimeter. So you can see there's a distinct particle difference between what would be considered material in a sandstorm and material in a dust storm. It's usually on the realm of 70% sand and 10% clay and 20% silt or something like that for a sandstorm, and kind of the flip-flop for a dust storm, with primarily clay being entrained with a smaller portion of silt and a much smaller portion of sand. As the name suggests, sandstorms describe an exceptionally strong wind which picks up and carries a large amount of sand into the atmosphere. They can reach heights of 10 to 50 feet and are most commonly found in desert regions worldwide. In contrast, dust storms carry much smaller particles, which can be carried higher and further. It's easier for those to overcome the forces of gravity and remain buoyant. The strength of the microburst can determine the height to which some particles travel, with some being recorded at nearly a mile in the air. Dust storms can happen anywhere if there is dry enough exposed land with loose sediment. Any dust storm, sandstorm, or haboob will significantly reduce visibility, creating hazardous travel conditions. In addition, that air can be dangerous to inhale because of the particles that are being picked up by the storm. And we've had some very famous dust storms here in the United States. The Dust Bowl era is really characterized by lots of dust blowing around because of a whole lot of different things. In the 1930s, drought had basically covered the entire plains for nearly a decade. The drought's direct effect is most often remembered as agricultural. Many crops were damaged by deficient rainfalls, high temps, and high winds, as well as insect infestations and the dust storms that come with these types of conditions. The resulting agricultural depression contributed to the Great Depressions, bank closures, business losses, increased unemployment, and physical and emotional hardships. And this was really kind of stemming from the 1920s. Although records focus on other problems, the lack of precipitation would have also affected wildlife and plant life and would have created water shortages for domestic needs. A number of poor land management practices in the Great Plains region had kind of primed this and increased the vulnerability of the region before that the series of 1930s droughts kind of struck. Some of the land use patterns and methods of cultivation in the region can be traced back to the settlement of the Great Plains nearly 100 years prior. At that time, little was known of the region's climate. Several expeditions had explored the region, but they were not studying it for potential agricultural use. And furthermore, their findings went into government reports that were not readily available to the general public. During the 1930s, many measures were undertaken to relieve the direct impacts of drought and to reduce the region's vulnerability to dry conditions. Many of these measures were initiated by the federal government, which was at this time a pretty relatively new practice. Before the 1930s droughts, federal aid had generally been withheld in emergency situations in favor of individuals and self-reliant approaches. This began to change with the development of the Great Depression in the late 1920s and the 1933 inauguration of President Franklin Delano Roosevelt. The Depression helped soften deep-rooted hardline attitudes of free enterprise, individualism, and the passive role of the government. This was a direct quote, thus paving the way for Roosevelt's New Deal programs, which in turn provided the framework for drought relief programs in the Great Plains. So these associated dust storms, these events, really kind of propelled that major change in our governmental system here in the United States. So this Dust Bowl era, which you can see is a term coined by Associated Press reporter Robert Geiger in 1935, really was the impetus for a lot of change here in our country. And it all stemmed from very poor land management practices, drought, lack of precipitation, high temps, all of these things that we've been learning about kind of coming together and leading to pretty degraded conditions throughout the Great Plains region of the United States. So you can kind of see these have a major impact when they do happen. And you can see this photo here from I think 1935 or so. I think, let me see. Yes, okay. April 14th, 1985. It's kind of tough to read that sometimes. But this photo shows this massive wall of dust moving likely towards the photographer near the town of Beaver, Oklahoma. So pretty interesting phenomena. Now we can monitor things a little bit differently. We have a much better idea and understanding of land management and associated practices, but that doesn't mean that it's necessarily vastly improved. Obviously, we know that we can't leave wide swatches of land open for wind action, and that's still something we're actively researching this day. But we can also monitor these types of things with satellites. So there are two sensors. So the MODIS and VIRS sensor on the Terra and Aqua satellites that are very important. So data from NASA's land atmosphere near real-time capability for EOS, Earth Observing Systems, LANCE, are used to monitor and predict dust storms. Aerosol optical depth, or AOD, or aerosol optical thickness, indicates the level at which particles in the air prevent light from traveling through the atmosphere. Aerosols scatter and absorb incoming sunlight, which reduces variability, or sorry, visibility. So we were able to see this from a satellite. We can see this is from the MODIS sensor, I believe, off the Terra satellite, is this image that we're looking at here on the right over portions of Jordan, Iraq, and Syria. That dust storm, you can kind of see a good portion of it. We'll kind of draw the diffuse boundary here. Somewhere over here and all the way down here. So look at how massive of an area this is. That's all actively blowing dust. The strongest portions seem to be right here, kind of more over western or eastern portions of Jordan and central portions of Iraq. But you can see this is all from satellite imagery. So the other one, AIRS, the atmospheric infrared sounder on NASA's Aqua satellite, gathers infrared energy emitted from the sun, from Earth's surface and atmosphere globally every day. Its data provides 3D measurements of temperature and water vapor through the atmospheric column, along with a host of trace gases, surface, and cloud properties. AIRS data are used by weather prediction centers around the world to improve their forecasts. They're also used to assess the skill of climate models and in applications ranging from volcanic plumes and detecting volcanic plumes to drought forecasting. So we can see here kind of a similar thing. We're looking for aerosols that are suspended in the atmosphere. So we use satellites to kind of monitor these things, aside from air quality stations across the world. Having lived in Arizona for 4 years, I was no stranger to dust storms and haboobs. We had them, particularly during the summer, pretty regularly. So there were two kind of stages. Obviously, you have a watch and a warning. Dust storm watch tells you where or when and where the dust storms are likely to occur. You watch the skies, stay tuned to NOAA, and stay tuned to kind of commercial radio and television for information. Dust storm warnings are issued when visibility is half mile or less due to blowing dust or sand and wind speeds exceeding 30 miles an hour or more. So dust storms, having driven in them, can reduce visibility to near zero in seconds, resulting in deadly multi-vehicle accidents on many roadways. So what we're seeing here on the right is the kind of quick hitting tips by the Arizona DOT on what to do and how to stay safe during traveling within dust storms. So we have in Arizona a monsoon season that starts around mid-June and ends by the end of September, which can be really cool. It can bring some beautiful but very unpredictable and regularly changing dangerous weather conditions. From heavy rains that will cause slick roads and low visibility to these haboobs, which we talked about, are kind of preceding the monsoon, that can basically lead to blackout conditions. Monsoon driving can be incredibly dangerous. So the dust will hit, and then the monsoon storms will smash in right after that. So if you're ever traveling down there, you exit the highway if you can, pull completely off the roadway, turn off your vehicle headlights and marker lights, because a lot of times people will try to follow traffic. So if they don't realize you're stopped because visibility is so low, they'll just slam right into the back of you. Set your e-brake on and take your foot off the brake. Stay in your vehicle with the seatbelt buckled and be patient and just wait for that storm to pass. It's not going to be long. These things come and go very quickly. So if you're ever finding yourself in one, just take it easy and just kind of wait it out. You don't want to be breathing it in, because things like valley fever, so this is spread through fungal spores, which are entrained during dust storms. So you can actually get valley fever and get very, very sick. You also don't want to breathe that in, because you don't want silica getting into your lungs. There's a condition called silicosis, where you basically got these small little particles grinding and grinding and grinding within your lung tissue, and that's not really what you want. In fact, just a quick story, because it was such an interesting change coming from living here in the Midwest all my life to moving down to Arizona for my PhD work. We were moving our stuff in off of our U-Haul on like July 9th, I think it was, in 2018. And we are shutting the door on the U-Haul, and all of a sudden, my phone, my partner's phone, her family's phones who are helping us move, all of our phones start going off with these texts that say, pull aside, stay alive. Uh, and you see kind of, you see it here on this little thing. That's kind of their quick message. And we didn't know what was going on. And it was a dust storm warning is what was coming next. And I remember getting inside and basically everything outside became orange, as you saw in some of those preceding pictures. And then shortly thereafter, it rained sideways. So that was day one of our time in Arizona. Um, one more quick funny tidbit. My wife decided to give them a name. I told her that the dust storms were called Haboobs, and then you get the monsoons right after. And she says, "Oh, well then we can just call them Thunderboobs." So there's my full credit to her and her sense of humor. That was we still called them Thunderboobs for 4 years later. So yeah, it was very interesting living down there. It's basically like a blizzard, but everything is orange and you don't want to breathe it in. It's a very wild experience. So this all said, there are unfortunately increasing risks for these types of phenomena for a number of different reasons. So, if we look on I could have flipped these around, but if you look on the map on the right-hand side, you are looking at annual expected affected livestock risks of sand, oh my goodness, sand or dust storms around the world. Um, the interesting thing is here, we're looking at areas where dust storms can be particularly damaging from an economic perspective. There are other ways to look at this, but notice kind of in that, you know, 30 degrees, there are 25 to 35 degrees or so north and south, or north latitude here. This band here. Now, if we look at that map on the left, this is where it gets a little more concerning because if we notice the areas where desertification or the conversion of lands to deserts, where it's going to be most problematic, are on these fringe lands where we've got these major deserts that already exist, but based off of anthropogenic climate change, we're starting to see expansion of these desert regions. So as global temperatures rise and our human population expands, more of that planet is vulnerable to desertification. It's basically the permanent degradation of land that was once arable. So used for agriculture or potentially could be used for agriculture. So while interpretations of the term desertification vary, the concern centers on human-caused landscape degradation in areas with low or variable rainfall, arid to semi-arid or subhumid lands. These account for more than 40% of Earth's terrestrial surface. So while land degradation has occurred throughout history, the pace has accelerated, reaching 30 to 35 times historical rates, according to United Nations. This degradation tends to be driven by a number of factors, including urbanization, mining, farming, and ranching. So you can expect these areas of potential impact to only increase as we have more exposed sediment. We see it here in the United States. So this was an interesting study that was in the Journal of Geophysical Research Letters that shows that the average dust storms per year have increased from about 20 per year in the 1990s to about 48 per year in the 2000s, just within the Southwest United States. Researchers found that there was a combination between warmer sea surface temperatures in the North Pacific during the 2000s than during the 1990s, along with colder waters off the California coast. This allowed for cooler and drier northerly winds from the North Pacific into the southwestern US, helping to dry out the soil. Wind pattern also blocked warmer, moister air from the tropical Pacific. This contributed to increased dust storms in every season except summer, when plant cover and soil moisture was at its peak. So very interesting to see that we're seeing increases, and we can see cases of valley fever from 160 to almost 1500 in both Arizona and California. We can see that there are massive increases in dust storm concentrations kind of throughout Colorado, southern Colorado, New Mexico, Arizona, into Texas. So these are only going to be worse. They're only going to get worse as we continue to struggle and deal with the impacts of anthropogenic climate change. So there is our dust storms, haboobs, and sandstorm lecture. The next one, hopefully, is going to be interesting. Again, it's a topic I'd never learned about until very recently, and it's meteotsunamis. So I hope you enjoyed this one, and we will see you in the next video. Thank you.